So in my previous video, I did the same problem by switching each inequality into slope-intercept form, into y equals mx plus b form. I actually prefer this method when they're in standard form. All you do is make x equals 0 to solve for y, and then make y equals 0 to solve for x. So if I make x equals 0, my top inequality becomes negative 10y is less than or equal to 60. Because if x equals 0, so does 40 times 0. 40 times x is also 0. So I divide by negative 10, and I get y is greater than or equal to negative 6. I put a dot right here at negative 6. Then I do the same thing. I make the y value equal 0, and I get 40x is less than or equal to 60. I divide both sides by 40, and I get that x is less than or equal to 1.5. So I'm going to try to squeeze that in. That looks like 1.5. Then I can connect my dots with a solid line because it was a or equal to problem. Like that. And check it out. I have two inequalities here. And you might be saying, how do I get both these inequalities to be true? Well, the first one says y is greater than or equal to negative 6. So I know I need to shade up from that. And the second one says x is less than or equal to 1.5. So I need to shade to the left from that. And that shows me that I'm going to shade up and to the left from my boundary line. It's pretty nice when you have the same answer from both your inequalities. If you don't have the same answer, something went wrong. Now I'm going to do the other inequality with the same method. If I make x equals 0, then negative 4x disappears, and I have 8y is less than or equal to 24. Divide both sides by 8, and I get y is less than or equal to 3. Let's put that dot right there. I'm going to shade below that dot. If I make y equals 0, I have negative 4x is less than or equal to 24. Divide both sides by negative 4, and I get x is flip the direction because it's a negative. X is greater than or equal to negative 6. That looks like it's right about here. Kind of hard to see, but that seems good. Connect your two dots with a solid line. I shade to the right from my x-intercept, and I shade below my y-intercept, and I get this whole region here. Of course, the region that we actually care about is the double shaded region, which is this purple zone right here. Any point in that purple zone is a solution to both of the inequalities. And by the way, my favorite point, the easiest point, 0, comma 0, is in the purple zone. And you should be able to check with your check by yourself that really works. If I make x equals 0, I have 0 minus 0, and that is clearly less than 60. And if I make x 0 and y 0, I get 0 plus 0, which is clearly less than 24. So we can tell that 0, comma 0 is a solution to the system. It's not the only solution. Every point within the purple region, which goes on forever, is also a solution. So I could choose the point where x is negative 100 and y is negative 500, and that would also be, or negative 300 would also be in the solution zone.